Okay, we're going to be talking about matrix arithmetic now. So when we think about arithmetic, we should be thinking add, subtract, multiply, divide. Only we're going to be adding, subtracting, multiplying, and dividing matrices instead of numbers. The easiest thing to do when we talk about matrix arithmetic is addition and subtraction. And anytime that we want to add or subtract matrices, you can only add or subtract matrices that are exactly the same size. So if we look at matrix A, 2 by 2, and matrix B, also 2 by 2, because those two matrices are the same exact size, it's okay to go ahead and talk about adding and subtracting them. In fact, if they ask us to find matrix A plus B, that will also be a 2 by 2 matrix. And if we're looking to get the first entry up here in the upper left, we're just going to add the first entries of A and B. So 0 plus 5 is 5. Continuing, -2 plus -1, -3. 2 plus 3 is 5, and 3 plus 0 is 3. Similarly, subtracting two matrices, we're going to do the same thing. We're just going to subtract the entries of A and B. 0 minus 5, -5. When we're looking at -2 minus -1, remember that when you subtract a negative, it's really the same as adding a positive. So -2 minus -1 is really -2 plus +1, -1. 2 minus 3, -1. And 3 minus 0 is 3. The other easy thing to do when you're talking about matrices is scalar multiplication. So scalar multiplication is different from matrix multiplication. Here, when it asks us to do 2 times matrix B, it's not asking us to multiply two matrices together. It's just asking us to take matrix B and multiply all of the entries by 2. Two times 5 is 10. 2 times -1, -2. 2 times 3 is 6. And 2 times 0 is 0. If matrix C looks like this and matrix D looks like this, I want you to note again that C and D are the same exact size. Now if they ask you to find 2C minus 3D, then they want you to take matrix C and multiply by 2, take matrix D and multiply it by 3, and then subtract the two new matrices. Go ahead and hit pause and see if you can do that on your own, and then resume the video to see my solution. Okay, 2 times C, we're just going to take matrix C and multiply all of the entries by 2 to get 4, -4, 6, 8, 2, and 0. I'm going to put up my subtraction sign, and because I'm copying that subtraction sign, I'm not multiplying by -3, I'm just multiplying by a +3. So taking D and multiplying by 3, -3, 24, 6, -6, -12, and 9. And now we'll just go ahead and subtract the two matrices to get the answer. 4 minus -3 is 4 plus 3, or 7. -4 minus 24, -28. 6 minus 6, 0. 8 minus -6, 8 plus 6, 14. 2 minus -12, 2 plus 12 is 14 again, and 0 minus 9, negative 9. My answer would look like this. To state the size of a matrix, you're going to list the number of rows first, then the number of columns. So to state the size of matrix D in the previous example, so I'm looking up here at matrix D, I want you to notice that D has 1, 2, 3 rows and 1, 2 columns. So rows first, then columns. Because D has 3 rows and 2 columns, we can write that D is a 3 by 2 matrix. Okay, matrix multiplication. This is when things get a little bit more complicated here. First, you can only multiply matrices when the number of columns in the first matrix is the same as the number of rows in the second matrix. So here we have 2 matrices. The first matrix is m by n. That means it has m rows and n columns. And then we're being asked to multiply that by another matrix that is n by p, which means it has n rows and p columns. What I want you to notice is that the first matrix had n columns, so the number of columns in the first matrix was the same as the number of rows, n, in the second matrix. And because those are the same, that's what tells us that it's okay to go ahead and multiply the matrices together. And when you're looking for the size of the new matrix, you're going to take the rows from the first matrix and the columns from the second matrix to get the size. So it would have m rows and p columns, which means when I multiply an m by n times an m by p, my answer should be an m by p matrix. Let's go ahead and take a look at an example. Notice matrix A is 2 by 2 and matrix B is 2 by 2. So obviously the number of columns in the first matrix would have to be the same as the number of rows in the second matrix because both of them have 2 rows and 2 columns. So we can talk about multiplying A and B together, multiplying B and A together, and even B times B since they're all 2 by 2 matrices. Anytime we do matrix multiplication is rows by columns. In fact, we're always going to take the rows from the first matrix and multiply that by the columns of the second matrix. So if we're being asked to multiply A times B, then A is the first matrix and B is the second matrix. So I'm going to multiply the rows of A by the columns of B. Let's take a look at how we do that. So we're going to start by grabbing the first row of the first matrix. So the first row of the first matrix is this -3, 2. And I'm going to write that out front here in front of B like this because, as I said before, I'm going to multiply the rows of A by the columns of B. In fact, when I'm looking to get the first entry into matrix AB, the first entry up here is going to be the first row of A, which we've already written out front, times the first column of B. And what you do is you multiply first. -3 times 0 is 0, and 2 times -2 is -4. And then you're going to add those two numbers together. So 0 plus -4 is -4, my first entry. When I want the next entry over here, I'm going to take that same row, negative 3, 2, which is still written out front here, and now to get the first entry, we multiplied by the first column. To get the second entry, we're going to multiply by the second column over here. So now we're going to multiply this negative 3 times this 2 to get negative 6, and 2 times 4 to get 8, and then negative 6 plus 8 is 2. And I want you to notice at this point, you've taken that first row, and it gave you the first row of the answer. There are no other columns, right? To get the negative 4, you multiplied by the first column. To get the 2, you multiplied by the second column. And now you're out of columns here. So now you're ready to start the second row of your answer, which means now we want to grab the second row of the first matrix right there. So I'm going to go ahead and erase that negative 3, 2 that I just wrote out front. And now I'm going to write the second row of the first matrix, 2, negative 2, out front here. Because now that we're moving on to the second row of the answer, I need to use the second row of the first matrix, and then to get the first entry, you're going to multiply by the first column. So we're doing 2 times 0 is 0, and negative 2 times negative 2 is 4. 0 plus 4 is 4. Now go ahead and multiply by the other column. This 2 times this 2 is 4, and negative 2 times 4 is negative 8, and 4 plus negative 8 is negative 4. And that is how you would find matrix AB. Let's go ahead and look at matrix BA next. So I'm going to go ahead and erase everything that we've done up here again. And what's different when we start to talk about matrix BA is now B is my first matrix and A is my second matrix. So I want to multiply the rows of B by the columns of A. And when we're trying to get the answer here, we want to start with the first row of the first matrix. So now we're focusing our attention here on this first row, 0, 2. And we want to multiply that by the columns of the second matrix, or the columns of A. So I'm going to take that row 0, 2 and bring it out front here. And again, to get the first entry, I just multiply by the first column. 0 times negative 3 is 0, and 2 times 2 is 4, and 0 plus 4 is 4. Now we're going to take that same row and move over to the next column. 0 times 2 is 0. 2 times negative 2, negative 4. 0 plus negative 4, negative 4. And we finished the first row because we're out of columns to multiply by. So again, we'll go ahead and erase that 0, 2. And now we're going to grab the second row of that first matrix, which is now matrix B. Negative 2, 4. We're going to go ahead and put that negative 2, 4 out front here. And now we'll go ahead and multiply by the first column. So negative 2 times negative 3, positive 6. 4 times 2 is 8, and 6 plus 8 is 14. Okay, for our last entry, just go ahead and take that same row, negative 2, 4, and multiply by the remaining column. Negative 2 times 2, negative 4. 4 times negative 2, negative 8, and negative 4 plus negative 8 is negative 12. And what I would like you to notice right now is that matrix AB is not at all the same as matrix BA. So AB completely different than BA, and these are rarely the same. Okay, the next problem asks us to do B squared, so an exponent here. Remember that B squared is really the same as B times B. So this is asking us to multiply B times itself, which means we want the rows of B times the columns of B. So we're not even going to look at matrix A at all. We're going to focus all of our attention here on matrix B. And if we start with the first row of matrix B, that's already highlighted from our previous problem, that was this 0, 2 running this way. So I'm going to take that 0, 2, and I'm going to go ahead and write it out front like this, because I want to multiply that row, 0, 2, by that first column of B. So now I'm doing 0 times 0, 0, 2 times negative 2, negative 4, and 0 plus negative 4 is negative 4. We're going to take that same row and move over to the next column over here. 0 times this 2 is 0, and 2 times 4 is 8, and 0 plus 8 is 8. And now we're finished because there's no more columns. So again, I'm going to erase the 0, 2 out front. And now because we're moving on to that second row, we're going to grab the second row here, negative 2, 4. I'll go ahead and write that negative 2, 4 out front here. And to get the first entry, multiply by the first column. Negative 2 times 0, 0. 4 times negative 2, negative 8. And 0 plus negative 8 is negative 8. Finally, to finish, negative 2 times 2, negative 4. 4 times 4, 16. And negative 4 plus 16 is 12. Answer looks like this. Okay, so that's 2 by 2 matrix multiplication. Again, it was the rows of the first matrix by the columns of the second matrix. As I flip the page here, we're going to go ahead and get into some larger matrices. So instead of 2 by 2, we'll be looking at some matrices that are a little bit bigger now. Okay, in fact, when we look at matrix A, think about the size of matrix A. Remember when we talk about size, we said rows by columns. Matrix A has 1, 2, 3 rows and 1, 2 columns, 3 by 2. Matrix B is different in size. In fact, matrix B has 1, 2 rows and 1, 2, 3 columns, 2 by 3. Let's start by seeing if we can find matrix AB. So A is my first matrix, B is my second matrix. So we're going to do the rows of A by the columns of B. So we're going to start by grabbing the first row of the first matrix, that negative 1, 3, and we're going to put that negative 1, 3 out front here to multiply by all 3 columns of matrix B. To get the first entry, multiply by the first row. Negative 1 times 0, 0. 3 times 1 is 3, and 0 plus 3 is 3. Okay, move on to the middle column. Negative 1 times negative 1, positive 1. 3 times 2 is 6. 1 plus 6 is 7. Negative 1 times 2, negative 2. 3 times negative 4, negative 12. Negative 2 plus negative 12, negative 14. And at this point, we are out of columns. So we're going to move on to find the second row. So I'm going to erase the negative 1, 3 out front. And we're going to grab the second row here, this 2, 1, and we'll write that out front now, like this. Okay, multiply by the first column. 2 times 0, 0. 1 times 1, 1. 0 plus 1 is 1. Moving on to the middle column. 2 times negative 1. Negative 2, 1 times 2, positive 2. Negative 2 plus 2, 0. 2 times 2 is 4. 1 times negative 4, negative 4. 4 plus negative 4, 0. And again, we are out of columns here, so we'll erase that 2, 1 that we just wrote out front. And now we're going to go ahead and grab that -3, -2 that we see right here and place that out front. Taking that -3, -2 and multiplying by the first column, I'm getting 0 plus -2. 0 plus -2 is -2. Moving on to the second column, I'm getting 3 plus -4, -1. Finally, the last column, -6 plus 8 is 2. And I want you to note the size of matrix AB, and let's see if the size of matrix AB makes sense. Remember, we said matrix A was a 3-row, 2-column matrix, a 3x2 matrix. And we said that matrix B was a 2-row, 3-column matrix, 2x3. What I want you to know is that here these two numbers are the same. And remember, we said the size of the answer would come from the rows of the first and the columns of the second. So it makes perfect sense that we get a 3x3 matrix. When we think about matrix BA, we're going to be now using B as our first matrix and A as our second matrix. So now we're going to be doing the rows of B times the columns of A. So I'm going to go ahead and carefully erase what we've done there. And when I want to grab the first row of B, the first row of B looks like this: 0, -1, 2. So I'll go ahead and write that 0, -1, 2 out front. And to get the first entry, I'm going to go ahead and multiply that 0, -1, 2 times the first column. So this time I'm doing 3 multiplications that will all get added together. So I see 0 plus -2 plus -6. So 0 plus -2 plus -6 is -8. Then when I move over to the second column, I'm getting 0 plus -1 plus -4, -5. And I want you to note already we're out of columns, right? So I just have 1, 2 columns, which means I just have 2 entries in that first row. We're going to move on now to the second row, which means I want the second row of matrix B. So the second row of matrix B looks like this: 1, 2, -4. Let's go ahead and erase again and write that 1, 2, -4 out front. Okay, again, 3 multiplications to add together. I'm seeing -1 plus 4 plus 12. So -1 plus 4 is 3, and 3 plus 12 is 15. Moving over to the next column, 1 times 3, 3, 2 times 1, 2, -4 times -2, +8. So 3 plus 2 is 5, and 5 plus 8 is 13. And at this point, no more columns, also no more rows to grab. So we're finished, and now we just have a little 2x2 matrix here for matrix B times A. All right, let's go ahead and do one last problem here. If they're asking for A squared, remember they're asking you to multiply matrix A times matrix A. So it wants the rows of A times the columns of A. So if we're looking at the rows of A, the first row of A would be this -1, 3 that we see here. And if I try to write that out front, -1, 3, I want you to notice I could multiply these together and these together, but there's not a number down here for me to multiply by that last entry. So in a sense, things are not lining up. So when that happens over here, you're just going to write that that matrix multiplication is in fact not possible. Okay, let's talk about why that was not possible. Remember, A had 3 rows, 2 columns. So A was a 3 by 2. So if you're trying to multiply a 3 by 2 times a 3 by 2, what I want you to notice is that the columns of the first matrix are not the same as the rows of the second matrix. And this is why that matrix multiplication is not possible. When you're doing a problem like this, you don't need to show the reason why it's not possible. You just need to write down the fact that you know it's not possible. Okay, so again, good point in the video, or good place rather in the video, to go ahead and hit the pause button so that you can go ahead and try to do the next problem on your own and then come back to look at the solutions. I'm not going to go through the whole matrix multiplication. I'll just quickly write down the answers so you can check them yourself. So go ahead and hit pause now and try those 3 problems on your own. Okay, hopefully for matrix AB, you got 9, 10, 10, 6, -4, 0. BA, if I take that 1, 3, 2, 1, 3, 2, and try to write it out front, things do not line up. So BA is again not possible. And finally, B squared. You were doing B times B. So you're grabbing rows of B, 1, 3, 2, multiplying that by columns of that same matrix B. This time I did get a large 3 by 3 matrix. First row, 13, 2, 6. Second row, 0, 7, 4. Third row, 11, 10.